So today we are going to be talking about unit circles and angles within that unit circle. So unit circle is a circle with a radius of 1. And so angle and standard position, there are 4 characteristics. The first is that the initial side is on the positive x-axis. And then the terminal side forms the angle. Positive angles open counterclockwise. So counterclockwise is this direction. And clockwise is this direction. That's what negative angles open. So then a reference angle is the acute angle formed by the terminal side and the x-axis. And so acute, if you've forgotten, is an angle that's smaller than 90 degrees. So first we're going to figure out how to sketch these things. So sketch 110. So your initial side will be on the positive x-axis. So that's your initial side. And then your terminal side is what's going to form your angle. So 110, you're not going to use a protractor, you're just going to guess. So that's 90, and the 110 is a little bit over, like right there, and that's the terminal side. So that's 110. So then to find the reference angle, what it is the angle between the terminal side that we just drew and the x-axis. So basically it's the quickest way that you can get to the x-axis. So from the terminal side all the way down there, that would be the reference angle. So in this case, this line right here is 180. So I do 180 minus 110, and my reference angle would then be 70 degrees. All right, so now negative 210. So I do my initial side, and then since it is a negative, what I'm going to do is open it up clockwise. So I'm going in this direction. So that is 90, negative 90. That's negative 180. So negative 210 would be around right there. All right, so then I need to find my reference angle. So it's the angle between this terminal side and the closest x-axis, so right there. So we know that this was 180, so to get to 210, that'd be 30 more degrees. So my reference angle is 30 degrees. So now for degrees, a degree is an angle expressed in decimals. So an example would be below. So if you notice they have decimal points in them, you're not going to see a fraction in degrees. So then radians is another way of expressing degrees. It's like inches and centimeters. It's an angle measured as a portion of the circumference of the unit circle. It's arc length. And so these are most commonly going to be expressed as fractions, as you can see from the examples. And so what we're going to work on is converting from degrees to radians or radians to degrees. And so I'm going to show you how these dead old guys came up with the conversion. So unit circle has a radius of 1, so the circumference. So if you have forgotten, circumference is 2 pi r. That's the formula. And so if the radius is 1 and I plug 1 in for r, the circumference of a unit circle is 2 pi. And so we also know that a full circle is 360 degrees. So that means that if something is circle is 360 degrees, that means it equals 2 pi, which is the same as circumference. So then I can divide both of these by 2, and that means 180 degrees equals a pi. So this pi is an expression in radians, and that 180 is degrees. So whenever you're finding conversions, you need to figure out what just 1 degree equals, or what just 1 radian equals. So if I want to figure out what 1 degree equals, what I do is I just take the 180 degrees, and I divide by 180, because 180 divided by 180 is 1 degree left over. And I have to decide that. So 1 degree equals pi over 180 radians. Now, if I want to go, so that's a conversion for the first. So then if I want to go the other way, if I want to figure out what 1 radian equals, I would divide both sides by the pi, because now I have 1 radian left over, and 1 radian equals 180 over pi. So that is the other conversion. So then when we go to our example, convert each of the following from degrees to radians, for radians to degree. If we're going from decimal degrees, so we already figured out that 1 degree equals pi over 180. And so all you have to do is multiply by pi over 180. So I take that 150 degrees and I times it by the conversion. And so how you're going to do this is you don't actually want to put the pi into your calculator. The pi is going to stay in your answer. And all you're going to do is reduce that. So you can go in your calculator and do 150 divided by 180, math, enter, enter. And if you do that, you get 5/6. I'm going to do the same thing. I'm going to multiply this by pi over 180. I keep the pi in my answer. Now I reduce negative 60 over 180, and that reduces to negative 1 over 3. I'm just going to put negative up top, and that's in radians. So now the next one, I talked about how you have to multiply by 180 over pi, okay, because that is what 1 radian equals. So you multiply by that to convert. So I take this and I multiply by 180 over pi. What that does is it cancels out those pi's. And then you could just multiply together the tops and multiply together the bottom. So you would do 3 times 180 up top, and you would divide it by 4. If you did that in your calculator, you get 135 degrees. Okay. The last one, it does not have the pi in it, so it was actually multiplied into the radians. So I still multiply by 180 over pi, but this just means when I grab my calculator, I'm going to have to actually do that. So I'm going to have to do 1.309. I'm going to times it by the top, 180. And I'm going to divide now by the pi. So pi is second and then the caret button. So it's 75 degrees.